Hello everyone, welcome back. So in this video we are going to learn about poles and zeros concept. Okay, so poles and zeros of a given system, right? So if you are first time to my channel, please consider subscribing. So generally the transfer function of any system, of a feedback system with negative feedback especially, is given by g of s by 1 plus g of s into h of s, as I have told you already. Okay, so g of s is the open loop transfer function, h of s is the feedback, okay, feedback unit, and its transfer function is given by this formula. So in standard form, what can we represent is 1 plus s tau 1 into 1 plus s tau 2 into 1 plus s tau 3 and so on, divided by s power n into 1 plus s tau a, 1 plus s tau b, 1 plus s tau c, and so on. Okay, so this is the general representation. So if you take the denominator of the transfer function and made it equal to 0, it is called as characteristic equation. Okay, so it is called as characteristic equation. So characteristic equation of closed loop transfer function is given by 1 plus g of s into h of s is equal to 0. Okay, so this is very important formula. So characteristic equation is given by the denominator made equal to 0 of the transfer function. So 1 plus g of s into h of s is equal to 0 gives you the characteristic equation, and roots of characteristic equation represents the closed loop poles of the system. Okay, so roots of characteristic equation represents the closed loop. Very important point, roots of the characteristic. So characteristic equation is, if you are given with transfer function, take the denominator, so made it equal to 0, it becomes the characteristic equation. So if you made it equal to 0, because it is algebraic equation in S, so you'll get roots for that. Okay, so that roots represents the closed loop poles of the system. So what is the importance of closed loop poles? So based on closed loop poles, we can find the stability of the system. Okay, we can comment on the stability of the system, whether the system is stable or not. We can comment by seeing the location of this closed loop poles. Okay, so that location is obtained from roots. So that roots is again obtained from characteristic equation, and that characteristic equation is obtained from transfer function. Okay, so all these concepts are interrelated, right? So next is poles. What is actually poles? Okay, so what is poles? So what is the definition of pole? So poles are negative inverse of system time constant where the magnitude of transfer function becomes infinity. So if you take this denominator is equal to 0, so if you take this denominator is equal to 0, so because poles are obtained from taking denominator 0, so when denominator is 0, so this becomes g of s by 0. So g of s by 0 is going to be infinity. So magnitude of this transfer function is going to be infinity. So when magnitude of transfer function is infinity, so how can we write infinity as 1 by 0? So 1 by 0 is equal to this k into 1 plus s tau 1. Suppose only 1 0 is there, if you assume, into 1 plus s tau a, only one pole I am taking. So this cross multiplied, so you'll get s power n into 1 plus s tau a is equal to 0. So when you multiply this, you'll get 0. So 1 plus s tau a becomes 0. So 1 is equal to minus s tau a or S is equal to minus 1 by tau A. So this is negative inverse of system time constant, where the magnitude of the transfer function becomes infinity. So all those are called as poles. Okay, so directly also if you substitute this is equal to 0, you'll get this only. Okay, so you can directly write this, or you can learn the concept like this. Okay, so what are zeros then? Zeros are negative inverse of system time constants, or constants if you have multiple poles, where magnitude of transfer function becomes zero. So if the magnitude becomes 0, what will happen? So 0 is equal to k into something, 1 plus s tau 1 divided by 1 plus s tau A, as we have seen in the previous case. If you have Sn also, you can write. So if you cross multiply, so you can write 0 as 0 by 1. So if you cross multiply, so this will become n plus s tau 1 is equal to 0, or s is equal to minus 1 by tau 1. So negative inverse of system time constants, where the magnitude becomes 0. Okay, so or you can also equate the numerator of the transfer function equal to 0, so you'll get the same thing. Okay, so simply this is the definition, and this is how actually poles and zeros are calculated. Or simply what can we say is, poles is obtained by equating denominator of transfer function is equal to 0. If you equate denominator of transfer function is equal to 0, you'll get the closed loop poles of the system. And if you equate numerator of transfer function, if you equate it 0, so you'll get zeros of the corresponding system. Okay, so this is how we can obtain poles and zeros of the given system from the transfer function. Okay, so next, what are these zeros and poles is? So poles and zeros are addition of L and C components only. Okay, so if you add one of the L and C components, okay, so you'll get one more additional pole or zero may be obtained based on whether you are connecting in forward direction, that is only on the input, and or feedback, that is connecting both input and output. Okay, so if you take RC circuit first. Okay, so what is transfer function here? So V naught of S. So if you take this as V naught of S and this as Vi of S, R, and this is C. So V naught of S by Vi of S is equal to impedance across output, that is impedance across capacitor, divided by 1 R plus 1 by SC. So this becomes 1 by SCR plus 1, or we can write it as 1 by RC divided by S plus 1 by RC. So in this case, pole is only 1, so it is S is equal to minus 1 by RC. So if you add an inductor here, so this is V naught of S, one more storage element is added to this circuit. Okay, so this circuit consists of only one pole, so it is because of only one storage element. Okay, so if you add one more storage element, that is inductor also, then what is V naught of S by Vi of S is equal to impedance across output is 1 by SC by total impedance R plus SL plus 1 by SC. So it will become 1 by S square LC plus SCR plus 1, S square LC plus S square plus 1. So if you take LC as common, so what you'll get? So this is equal to 1 by LC divided by S square plus S into S into RC by LC plus 1 by LC. So it will now 1 by LC divided by S square plus R by L into S plus 1 by LC. Sorry, 1 by LC. Okay, so if you see here, what will happen? So the algebraic equation is the highest power is S square, so we'll get 2 poles here. Okay, 2 poles here. So why? Because we have added one extra storage element to this circuit. So for this circuit you have only one pole, and for this circuit now we have 2 poles. Okay, so poles are zeros or nothing but addition of the system storage elements or system time constants to the system. Okay, so this is the concept of poles and zeros. Okay.